My dear students, welcome to chemistry class. In the previous video, we discussed about balancing redox reactions by oxidation number method. Here we are going to balance the redox reactions by ion electron method or half reactions method. So both are same, ion electron method or half reaction method. First you have to learn some steps. After learning the steps, you can easily balance the redox reactions. So step 1, follow the step. So take one notebook and write the steps, then apply the steps on the balancing. You can easily balance the chemical reactions. First, assign oxidation number. Assign oxidation number method. So first assign oxidation number. Number 2, write. So before writing this ionic equation, you have to identify. Number 2, step 2, that is identify which is oxidized and reduced. Okay. Third step, write ionic equation. Write ionic equation. Then step 4, write half reaction. Write half equation. Write half equation. Then step 5, balance the element which is oxidized and reduced. Now step 5, balance the element which is oxidized and reduced. Step 6, balance oxygen and hydrogen. So to balance oxygen, add H2O. To balance hydrogen, add H plus. This is very important in this balancing redox reaction by using ion electron method. You have to add H2O to balance oxygen. You have to add H plus to balance hydrogen. Okay. Step number 7, balance electrons, number of electrons. Then step 8, check all balanced. Okay, so that's all about the steps. Now we will see example. Okay, I will show how to balance this redox reaction by using this ion electron method. So this is the equation, KMnO4 plus FeSO4 plus H2SO4 gives MnSO4 plus Fe2SO4 thrice plus K2SO4 plus H2O. So this is the given equation. Now we are going to balance this equation by using ion electron method or half reaction method. Okay. So first step, assign oxidation number. So we have to assign oxidation number for all the atoms. Whatever atoms present in this equation, we have to assign oxidation number. Okay. So potassium, this is +1 always, and oxygen always -2. So there are 4 oxygen atom. So total -8. Now remaining -8 plus 1, that is -7. Sorry. +7. So when it comes +7 plus 1, we will get +8 and this -8 will be cancelled. Okay. So K plus plus 1, manganese plus 7, oxygen minus 8. Clear? So for 1 oxygen, that is minus 2, 4 oxygen is there, so minus 8. So minus 8 plus 8, it will become 0. We have to check the total compound, that always the oxidation number for this total compound will be 0, equal to 0. So here 0. Now iron. See, for sulfate always minus 2, you have to take this whole sulfate always minus 2. Of course, this iron will get plus 2. Okay, plus 2 minus 2 will be cancelled. So total oxidation number will be 0 for this compound. Hydrogen, it will be, there are 2 hydrogen atoms, so plus 2. This sulfate, this is minus 2. Okay, so plus 2 minus 2 will be cancelled. Now here manganese, this is plus 2, sulfate, this is minus 2. Sulfate means SO4. Okay, so this whole SO4, the oxidation number is minus 2. Here also SO4 minus 2, and here also SO4 minus 2. For SO4, the oxidation number is minus 2. Okay, so that's what I wrote here. Next, here SO4, for 1 SO4 we will get minus 2. So there are 3 sulfate SO4 ion is there, so it will become minus 6. Then here it will be plus 6, and here there are 2 iron, or the iron atom is here, so for 1 iron atom it will become plus 3. Okay, that is the oxidation number. Oxidation number for 1 iron, that will be plus 3. So there are 2 iron atoms there, so it will become plus 6. So plus 6 minus 6 will be 0. Then here this sulfate minus 2, potassium plus 2, oxygen minus 2, hydrogen plus 2, because 2 hydrogen atoms are there, so 2 into plus 1 plus 2. Okay, so plus 2 minus 2 will be 0. Okay, now step 1 is completed. We are going to step 2. Step 2, identify which is oxidized and reduced. So you have to identify which is oxidized and reduced. Okay, see, for 1 potassium atom plus 1, then check this side, here also 2 potassium atoms there. So for 1 potassium atom it is plus 1, so there is no change here, so you can leave it. Then check manganese, Mn, oxidation number is plus 7 here. Then check this side, product side, manganese is plus 2. So oxidation number is decreased. So here some changes are there, so you have to select this one. Okay, now manganese is reduced. Next one, oxygen, there is no change. Here also for 1 oxygen atom minus 2. Here you can check everywhere oxygen is minus 2, so you can leave oxygen atom. Then next, iron, here plus 2. Then this side you check, this is plus 3. So here some changes in the oxidation number. So you have to choose this iron also. Okay, so this K1O4 here to here some changes. You see, in this compound and this compound, manganese showing some changes, and here FeSO4, here Fe2SO4 thrice, here iron showing some changes. So other than these 2 compounds, there is no change. Okay, here H2 there is no change, plus 2, here also plus 2, for 1 hydrogen plus 1, so here no change. Then sulfur, there is no change here, right? Now you have to write ionic equation. This is step 3. So manganese changes from plus 7 to plus 2. Iron Fe, it changes from plus 2 to plus 3. Okay, so we have identified oxidized and reduced atoms. Now step 3, here you should understand about ionic equation. Ionic equation means, right, you have to select cation and anion. I think in the lower class you have studied about anion, cation. So what is cation? Cation, it means positive ion, anion that is negative ion. So in any compound means it consists cation and anion. So we have to find out which is cation and which is anion. Here in this KMnO4, potassium is cation and manganese is anion. Okay, this is cation and this is anion. Cation, anion. Okay, cation means positive charged ion and anion means negative charged ion. Now check here FeSO4. In FeSO4, this ion is anion. This is cation and this is anion. Okay. So now check whether anion is oxidized or reduced or cation is oxidized or reduced. Now choose that ions and write as the equation. Okay. So in step 3 we are going to write the ionic equation. Here anion is oxidized. So anion shows some changes in the oxidation number. So select MnO4 minus plus here Fe2 plus, only cation showing some changes. So Fe2 plus gives here Mn2 plus, because here in this MnSO4 this is cation and this is anion. Okay, so cation showing the changes in oxidation number. So we are selecting Mn plus 2 because manganese ion is that charge is 2 plus here Fe3 plus. Okay, Fe3 plus. So the oxidation number here it is 3 plus, we are writing 3 plus here. Okay, next. So this is ionic equation. In step 4 we are going to write as the half equation. We are going to divide into half equation. So wherever manganese comes, select as one equation, and wherever iron comes and select as one equation. So MnO4 minus gives Mn2 plus, then Fe2 plus gives Fe3 plus. You can write 3 plus or plus 3, it's not a matter. Okay, both are correct only, because here plus 2 is here, I wrote here 2 plus, so there is no problem. So now we have written as half equation. MnO4 minus gives Mn2 plus, Fe2 plus gives Fe3 plus. So this is half equation. Okay, in step 5 we are going to balance the equations, balance which the element which is oxidized and reduced. Okay, so now step 5. So in step 5 we are going to balance the element which is oxidized and reduced. So MnO4 minus gives Mn2 plus and Fe2 plus gives Fe3 plus. Now here manganese is oxidized. Here one manganese is one here in the reactant side, and product side also only one manganese. So don't count this 2 plus 2 plus 3 for balancing. So to balance you have to put the number in front of the before this symbol, right? So don't confuse with these charges. So here only one manganese, here also one manganese, so there is no change. Here one iron, here also only one iron atom is there, so there is no No need to put any number to balance this equation. Okay. Next, step 6. We are going to balance oxygen and hydrogen. Here, how many oxygen atoms are here? MnO4 minus gives Mn2 plus. So there are 4 oxygen atoms are here. To balance oxygen, we have to add water. So add water here. Okay. So I am going to add water here because oxygen is there. To balance oxygen, we have to add water. So how many oxygen atoms are here? 4 oxygen atoms are here. I am going to add 4 here on the product side. Clear? So here 4 oxygen atom. So now oxygen atom is balanced. Next step, to balance, add water to balance oxygen. Okay. Now add H plus ion to balance hydrogen. Okay. Now product side, you see 8 hydrogen atoms are here. So to balance hydrogen atom, we are adding H plus on the reactant side. Okay. So H plus, how many hydrogen atoms are here? 8 hydrogen atoms. So I am going to add 8 H plus here. Okay. Hope you understood this step. In step 5, we have balanced the atom which is oxidized and reduced. So there is no change in the balancing. So all are equal. So I don't put any number here. Now in step 6, we are going to balance oxygen and hydrogen. To balance oxygen, we are adding water. That means H2O. To balance hydrogen, we are adding H plus. Okay. Now you see here 4 oxygen atoms are here. So that I add 4 water molecules. After putting 4 water molecules, so number of hydrogen is increased. Here 8 hydrogen atoms are here. To balance this hydrogen atom, I am adding here H plus. So 8 H plus, I put it here. Okay. Next, Fe2 plus. Here there is nothing is there, no oxygen, no hydrogen. So write as it is Fe3 plus. Okay. Now step 7. This is very important. Listen carefully. MnO4 minus plus 8H plus Mn2 plus 4H2O. Next Fe2 plus gives Fe3 plus. Now we studied in the oxidation and reduction. What is mean by oxidation and what is mean by reduction? Oxidation, that means loss of electron. Oxidation means loss of electron, and one more definition, increase in oxidation number. Increase in oxidation number. Reduction. Reduction, what is the meaning of reduction? Gain of electron. Gain of electron. Decrease in oxidation number. Decrease in oxidation number. Clear? So, now oxidation and reduction you know very well. Here which is oxidized and which is reduced also you know very well. Okay. Now here in step 7 we are going to balance electrons. So find out which is oxidized here. Here manganese, is it reduced or oxidized? Here we calculated in that first step, manganese is +7 and here manganese is +2. Okay, and here +2 for iron and here +3. This is the oxidation numbers we have calculated. Okay, so from +7 to +2 and here +2 to +3. Now check which is oxidized and which is reduced. Here you see oxidation number decreased. So that is reduction. Okay. Reduction, what is the meaning of reduction? Reduction means gain of electrons. Clear? So understand the concept here. Manganese, there is oxidation number +7. It is decreased to oxidation number +2. So this is reduction. Okay. Reduction. And you check here Fe2 plus oxidation number +2 and oxidation number here +3. So this is oxidation. Okay. So oxidation means loss of electrons. So always in the equation, loss of, whenever loss comes, right on the product side there is plus. How many electron lost? So increase in, what is, see the difference? Difference is only 1. So that is, it is increased, that is +1, +2, +1 we are getting +3. So number of electrons lost, that is only 1 electrons. Clear? 1 electron is lost here. So loss of electron, oxidation, you have to write, always write the electron on the product side. Okay. So don't write here on the reactant side. Now come to reduction. Here how many, reduction means what? Gain of electrons. So how many electrons gained? 5 electrons are gained. That gained electron means right on the reactant side. So this is reactant side. So I am writing 5 electrons gained. So that oxidation number decreased. Clear? You see electron always, note down here, electron, that is negative charge. Electron always having negative charge. Okay. So negative charge means whatever number comes, so put minus symbol before the number. See here +7. How many electron gained? -5 electron gained. So what is the net charge? +2. That is the meaning. Okay. So +7 -5, that is +2. So gain of electron, that is we are writing +5 here, and loss of electron, that is +1 on the product side. Okay. Now we are going to balance electrons in step 8. Sorry, in step 7 we are going to balance electrons. Okay. So how can you balance? Here MnO4 minus plus 8 electrons, sorry, 8 hydrogen plus 5 electrons, Mn2 plus 4 H2O. Here Fe2 plus gives Fe3 plus 1 electrons. Okay. Now here 5 electrons are here. Now we are balancing only electrons. Balancing electrons only. Okay. To balance electrons only, here 5 electrons are here. Here only 1 electron. So right here this is equation 1 and this is equation 2. In equation 1 only 5 electrons. In equation 2 only 1 electron. So I am multiplying here by 5 and here I am multiplying by only 1. Okay. So finally what will be the answer? MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O, then Fe2 plus, here we are multiplying 5, so put 5 here, 5 Fe3 plus 5 electrons. Clear? Now cancelling, we are cancelling whatever that same elements come, we are cancelling. Okay. So now here this ion and this electrons, 5 electrons are here. See, you have to cancel. See here, this step you listen carefully. We have to cancel. See, if you check reactant side and product side. So this is equation 1 we keep and equation 2. Check equation 1 reactant side and check equation 2 product side. So what are the elements are equal, then you can cancel it. Here 5 electrons are here on the equation 1 reactant side and 5 electrons are on the product side of equation 2. So we are cancelling 5 electrons. So anything else remaining? Nothing. Okay. Here Fe2 plus, here Fe3 plus. So they are different. So don't subtract here. Now add equation 1 and 2. So we are adding equation 1 and 2. So write reactant side, whatever components are coming, write on reactant side together, and product side whatever in both equations, so write all together. Okay. And finally we will get, so I am writing equation 1 on the reactant side, MnO4 plus minus plus 8H plus. Now come to equation 2 reactant side, only 5Fe2 plus. Okay, gives. Now come to equation 1 product side, Mn2 plus 4H2O. Now come to equation 2 product side, 5Fe3 plus. So this is step 8. Check everything is balanced. Okay, here you can check Mn, only one Mn, here 1 manganese, 4 oxygen, then 8 hydrogen, 5 Fe. So everything is balanced. So this is the final balanced equation by using ion electron method. Clear? So once again I will repeat this example once again. So listen carefully. So in the example, this is the example. First step, assign oxidation number to all the atoms. Second step, identify which is oxidized and reduced. If oxidation number decreased, that is reduction. If oxidation number increased, that is oxidation. Okay. Now in step 3, identify which is cation and which is anion, and in cation which is oxidized and which is oxidized in anion. So according to that, write ionic equation. Okay. So in step 3 we are writing ionic equation because we are going to identify which is oxidized and reduced in ions. Okay. MnO4, here manganese is, sorry, in KMnO4, MnO4 is showing change in oxidation number. So we are selecting MnO4. So same way Fe2 plus gives Mn2 plus plus Fe3 plus. In step 4, write half equation. So Mn on the reactant side, product side also Mn. So same component you write in as the one equation. In second half equation, write Fe2 plus, here Fe3 plus. So same element should come on both sides. Okay. In step 5, balance the element which is oxidized and reduced. So here we have balanced here in step 5. Then come to step 6. For oxygen, add water. To balance oxygen, to balance hydrogen, add H plus. Okay. So we have added here in step 6. Then step 7, write how many electrons gained and lost. So according to the oxidation reduction definition, for iron 1 electron is lost, and for manganese 5 electron is gained. So whenever you are writing gain means write the reactant side, and if electron is lost, write on the product side. Okay. So you are going to balance electrons only. So which side comes higher number, according to that put appropriate numbers, then multiply, you will get the balanced equation. Then finally cancel on both sides, which are the components are equal, you can cancel. So consider as equation 1 and consider equation 2. And both sides, one side reactant side you check, another side product side you check. If anything equal, you can cancel it. Finally add two equations. So write all the components present in reactant side. So we are writing all together on one side, and here we are writing all together on the product side. Okay, that's all. So this is the final equations. Okay students, so hope you understood today's class very well. In case if you have doubt, you can contact me. Thank you very much.